Okay, in this problem, we're going to look at, just to recall, we had a little bit of trouble with this, looking for the standard matrix in standard basis matrix representation of this linear transformation, and the linear transformation is described to you. So you actually have to draw out some pictures and think about this. So we start off with the first basis vector, 1, 0, and we do exactly what the transformation says. It says rotate this 2 pi over 3 radians. So there's 2 pi over 3 radians, and I cheated. I looked at the unit circle on the internet, but you can also get these numbers from your calculator once you've drawn them. What is the sine and cosine at 2 pi over 3? And you'll find that the coordinates are minus 1/2 and square root of 3 over 2. So E1 gets moved to the vector minus 1/2 square root of 3 over 2. The second move asks you to take that vector now and reflect it over the y-axis. So that's what we get when we reflect it over the y-axis. We get 1/2 and square root of 3 over 2. So the second move moves that original vector to 1/2 square root of 3 over 2. So that tells us that t of E1 is going to be 1/2 square root of 3 over 2. So now we've got to start all over again for the vector E2. And this is a little bit more tricky because you have to imagine in your head moving this vector an amount of 2 pi over 3 radians. So think about where that would be. It'd be a little bit more than 90 degrees over in the third quadrant. That angle right there turns out to be 7 pi over 6. And the coordinates of that vector are minus square root of 3 over 2 and minus 1/2. So the first move is to the vector minus square root of 3 over 2 and minus 1/2. Now I have to reflect over the y-axis as before. So if you just look at the coordinates, here the x values are going to be positive, but the y values are going to be negative. So I can automatically, from my first thing, get exactly what this is going to be. This is going to be square root of 3 over 2 and minus 1/2. So the second move is square root of 3 over 2 and minus 1/2, which gives us the end result. T of E2 is square root of 3 over 2 and minus 1/2. So now that I have these two results, I can form the matrix. The matrix is going to be T of E1 as the first column and T of E2 as the second column, and we arrive at this representation for A.